Estimating the sum with the alternating series. If the alternating series satisfies two conditions, 1. b sub n plus 1 is less than b sub n, the terms are decreasing. 2. The limits at n go to infinity of b sub n is 0. Then the series converges to some number s, which we don't know, but we can estimate it. The remainder is r sub n. It is the absolute value of s minus the partial sum s sub n, and this remainder will be less than the term b sub n plus 1. The alternating series is of the form b sub 1 minus b sub 2 plus b sub 3 minus b sub 4 plus b sub 5, and so on. Note that all of the b sub n terms are positive, but with n odd, we add b sub n, and if with n even, we subtract b sub n. Consider the graph of the partial sums s sub n of a convergent alternating series which converges to s. We see that the partial sums of the even terms are increasing and the partial sum of the odd terms are decreasing, and that is because the term b sub n are decreasing with the smaller magnitude. So these partial sums are approaching the sum s. If n is even, then s sub n is less than s sub n plus 1, where s sub n plus 1 is s sub n plus b sub n plus 1, which is an odd term, so we add. We see that s minus s sub n is less than b sub n plus 1. If n is odd, then s sub n is greater than s sub n plus 1. But s sub n plus 1 is now s sub n minus b sub n plus 1, because if n is odd, n plus 1 is even. And so s sub n minus b sub n plus 1 is less than s sub n. Rearranging the term, we see that s sub n minus s is less than b sub n plus 1. And so combining the two inequalities, we have s minus s sub n is less than b sub n plus 1. S sub n minus s is less than b sub n plus 1. To form an inequality, s minus s sub n in the absolute value is less than b sub n plus 1. But s minus s sub n is the remainder r sub n. So therefore, the remainder is less than b sub n plus 1.